Okay, so today we're going to be talking about inscribed angles in a circle. So again, just talking about arcs and stuff like that, just to remind ourselves. So if I have a circle, and maybe I need to actually use a pen this time. So I have a circle. Remember, I basically said if I have like a angle right there, the arc would be the equivalent, right? Well, today we're going to be more talking about angles like this, where we are coming off of the actual side of the angle, or of the circle. So like that, if that angle was 60 degrees, with inscribed angles, if they're not at the center, if they're at the other end, it's kind of like a radius, right? The radius, it was the same. But the diameter is twice the length of the radius, so if the angle is on the other end of the circle, the arc is going to end up being double that length. So this arc right here, from A to B, we'll call it, would be 120 degrees if its angle that's inscribed at the other end of the circle is 60 degrees. Okay? That's the property of the inscribed circle, is the arc is double what the angle is. Okay, so let's look at an example here. So here, it wants me to find the measure of arc EFG. It tells me this angle right here is 102 degrees. Well, that's the angle that would create the arc EFG, right? Well, it's on this end, so the arc would have to be double what that angle is. So 102 times 2 would be 204 degrees. Okay, pretty tough, right? Let's try this one. Number 3. This angle is what it wants me to figure out. It tells me the arc that is opposite it is 90 degrees. So again, the arc is double what that angle would be. So if I cut that in half, the question mark would have to equal 45 degrees, right? Pretty tough so far. Let's try this one. So this one wants me to find this angle. I know this arc is 74 degrees, and I need to figure out basically what this arc is, right? Well, fortunately for us, this is a diameter, which means if I take 74 away from 180, I should get this arc right here. So if I do that, I actually get 106, right? So that's the arc that's formed from that angle, but again, that would be double it. So if I cut that in half, the question mark here is going to be 53 degrees. Okay, not too tough. Let's try another one. Well, actually, these are all, you guys got it. Well, let's do one where it's x's. I'm going to have to zoom in here probably so you guys can see what it's talking about. Okay, so on this one, I'm given that this is 16x. So, and I know these arcs are 16x plus 5 and 22x plus 5. Well, there's no diameter, right? But I do know that this arc has to be twice the length of this x here, right? So if I were to do twice this x, I would get 32x. So that gives me 3 things that I know all add up to 180. There's actually a few ways I could approach this problem, but I'm going to set it up like this. So 16x plus 5 plus 32x plus 22x plus 5 all equal 360. And then I would take away the 2 5s would become 10, right? Take those away and I would get 16x plus 32x plus 22x equals 350. Then combine all my x's. 16 plus 32 plus 22 is going to be 70. X equals 350. Divide 350 by 70 and dun 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 dun, x is equal to 5. And that would be my answer. Okay? Not too bad. Again, it'll look like you didn't have all the pieces that you had, right? But put them all together. It's not that hard. Okay? And that is pretty much all you need to do the inscribed circles.